What's up, my dear students? It's Naresh Babu. Welcome back to Physics Crash. Students, in this session, I'm going to discuss about NEET previous year questions from Gravitation. Let us start the game. Gravitation. NEET previous year questions. Here the first question. The kinetic energies of a planet in an elliptical orbit about the Sun at positions A, B and C are K suffix A, K suffix B and K suffix C respectively. So here the diagram is there. So in this diagram, so one planet is revolving around the Sun. They have given its kinetic energy at position A, at position B, at position C are K suffix A, K suffix B and K suffix C respectively. AC is the major axis. So AC is the major axis here. BS is the minor axis. Okay. Here this BS perpendicular to AC. That means they have given SB is perpendicular to AC. So SB is perpendicular to AC at the position of the Sun, yes, as shown in the figure. Then it was given in 2018. So here we have options. From the options we have to find the relation between kinetic energies at position A, B and C. So here option 1, kinetic energy at A less than kinetic energy at B less than kinetic energy at C. Option 2, kinetic energy at A greater than kinetic energy at B greater than kinetic energy at C. Option 3, kinetic energy at B less than kinetic energy at A less than kinetic energy at C. And option 4, kinetic energy at B greater than kinetic energy at A greater than kinetic energy at C. Solution. See, we have formula for angular momentum, that is L is equal to mr square omega. Here m means mass of planet, r means distance of planet from the Sun, omega means angular velocity. So mr square means moment of inertia, that is I. So we got I omega. From that, omega is equal to L by I. So here we know kinetic energy half of I omega square. So from that, omega is equal to root over 2 Ke by moment of inertia, that is equal to L by I. So now I will do squaring on both sides. Then I will get kinetic energy is equal to L square by 2 times of moment of inertia. So from the above equation we can say kinetic energy is inversely proportional to the moment of inertia. So here moment of inertia at position A less than moment of inertia at position B less than moment of inertia at position C. Why? Because moment of inertia means mr square. So whenever r is more, moment of inertia will be less. Okay. So here at position A we have less moment of inertia. Why? Because here r is less, my dear, from the Sun. So compared to moment of inertia of B, at position A, moment of inertia is less. Like that, compared to moment of inertia at C, at position B, moment of inertia is less. Okay, compared to moment of inertia at position C. Why? Because C is at more distance from the Sun. So here we got the relation, that is moment of inertia at A less than moment of inertia at B less than moment of inertia at C. So whenever moment of inertia at A is less than moment of inertia at B, we can say kinetic energy at position A is greater than kinetic energy at position B. Why? Because kinetic energy is inversely proportional to moment of inertia. Similarly, kinetic energy at position B is greater than kinetic energy at position C. So from the options, option 2 is the answer, my dear. Now we will go with second question. A body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? It was given in 2019. So here the options: option A 150 Newton, option B 200 Newton, option C 250 Newton, and option D 100 Newton. Solution: given body weighs on the earth, that is W is equal to 200 Newton, G at a depth D. So acceleration due to gravity at a depth D, we have the formula, that is G at a depth D is equal to G on the surface of the earth bracket of 1 minus D by R. So here D means depth, R means radius of the earth. So at depth D, at R by 2, that means they have given how much will it weigh halfway down to the center of the earth. That means halfway down to the center of the earth means D will be equal to R by 2. So at depth D is equal to R by 2. We will get G at a depth D is equal to G bracket of 1 minus, in the place of D we have to substitute R by 2 by R. So on both sides I multiplied M with M. Why? Because we will get weight. So we have to calculate weight at depth D. So that's why I multiplied both sides with M. So mg at depth D means weight at depth D. Mg means weight on the surface of the earth, bracket of 1 minus, here R cancel. So we will get 1 by 2. So here weight on the surface of the earth they have given 200 Newton. So I substituted 200 Newton bracket of, here 1 minus 1 by 2 means we will get 1 by 2. Then 2 cancels 200 100 times, so we will get 100 Newton. So we got the weight of body down to the center of the earth. That means halfway down to the center of the earth, that is 100 Newton. So from the given options, option D is the answer, my dear. Now we will go with third question. The work done to raise a mass m from the surface of the earth to a height h, which is equal to the radius of the earth, is, it was given in 2019. So here the options: option A mgr, option B 2 mgr, option C half mgr, and option D 3 by 2 mgr. Solution: work done to raise a mass m against gravity, that is W is equal to mgh by 1 plus h by r. So at h is equal to r, in the above equation, in the place of h, if I substitute r, then I will get work done is equal to mgr by 2. So from the given options, option C is the answer, my dear. Now we will go with fourth question. A body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? It was given in 2020. So here the options: option A 48 Newton, option B 32 Newton, option C 30 Newton, and option D 24 Newton. Solution: given body weighs on the earth, that is W equal to 72 Newton, G at a height h, that is G at a height h is equal to G by 1 plus h by r whole square. So I will multiply with m on both sides to get weight at a height h and weight on the surface of the earth. So I got mgh is equal to mg by 1 plus h by r whole square. So mgh means weight at a height h is equal to mg means weight on the surface of the earth by 1 plus h by r whole square. So at h is equal to r by 2 and weight is equal to 72 Newton. So in the above equation we have to substitute in the place of h equal to r by 2, and in the place of weight on the surface of the earth 72 Newton. Then we will get weight at a height h, that is equal to 72 by 1 plus 1 by 2 whole square. So here 1 plus 1 by 2 means 3 by 2 whole square. So we got 72 by 3 by 2 whole square. So that is equal to 4 by 9 into 72. So we got 32 Newton. So we got the weight at a height equal to half the radius of the earth, that is 32 Newton. So from the given options, option B is the answer, my dear. Now we will go with the fifth question. So here fifth question, the escape velocity from the earth's surface is V. The escape velocity from the surface of another planet having a radius 4 times that of earth and same mass density is, it was given in 2021. So every year from gravitation, minimum one question they are giving, my dear student. So we have options here. Option A V, option B 2V, option C 3V, and option D 4V. Solution. Given escape velocity of the earth is V, let escape velocity of the planet is V suffix P, let radius of the earth is R, radius of another planet is 4r. Why? Because they have given radius of another planet is 4 times that of radius of earth. Okay, so escape velocity formula, that is escape velocity is equal to root over 2gm by r, where G means capital G means universal gravitational constant, m means mass of planet, okay, r means radius of the earth or radius of the planet. So it is escape velocity of any planet, that is V is equal to root over 2gm by r. So here 2g by r I wrote like that only, into m means mass, that is mass of planet, that is volume into density I can write in the place of m. So every planet is a sphere, so volume of sphere is 4 by 3 pi r cube into density. So that is equal to, so 2 into 4 8 we will get, so we will get 8 pi g rho by 3 under the root, okay, into r square. That means r cancels this r cube, so we will get r square. So we got root over 8 pi g rho by 3 r square. So from this equation we can say escape velocity is directly proportional to the radius of the planet. So from this we can write escape velocity of the earth by escape velocity of the planet is equal to radius of the earth by radius of the planet, that is r by 4r. So from the above equation we found velocity of the planet, that means escape velocity of the planet, that is 4 times of escape velocity of the earth. So from the given options, option D is the answer, my dear. So that's about this session, my dear students. I hope you like this session. If you like it, share it and subscribe it and have fun. Bye students.